DokaTruss. On a large job site, time isn't just money, it's momentum. That's where DokaTruss earns its place. It's more than just formwork, it's a smarter, faster way to handle slab pours, especially when every floor looks like the last. Instead of spending hours setting up beams, props, and panels piece by piece, crews roll in DokaTruss as a complete flying table. These tables are massive, up to 30 meters long and over 6 meters wide, yet are still manageable, thanks to a two-part configuration. Each table is built on a steel and aluminum truss frame, keeping the weight under 9.5 pounds per square foot. That's light enough for efficient handling but strong enough to support serious concrete loads. Support legs are spaced up to 12 feet apart, reducing the number of props and clearing up valuable workspace underneath. Crews can adjust the height on the fly with integrated jacks that offer up to 4 feet of travel. When it's time to move, there's no need to dismantle. Helix Steel Micro Rebar changes the way we reinforce concrete by blending reinforcement directly into the mix. These steel fibers, 30 to 35 millimeters long and less than 1 millimeter thick, are twisted into a helical shape that locks them into place once poured. Added at 10 to 18 kilograms per cubic meter, they create a 3D network throughout the slab or wall, boosting tensile strength up to 300 MPa. Unlike mesh or traditional rebar, Helix reinforces the entire structure uniformly, minimizing cracks and enhancing durability. The twisted form isn't just for show, it creates a mechanical bond that grips the concrete and resists movement. That means better performance under stress, fire, and time. It also simplifies construction: no tying steel, no placing mesh, fewer joints. Crews pour faster, and precasters skip steps. From heavy-duty industrial flooring to homes and tilt-up panels, Helix delivers consistent, embedded reinforcement that streamlines the job without compromising strength. Sugarcrete is changing how we think about building materials. Made from sugarcane byproducts like bagasse, these blocks are pressed, not fired, cutting out the energy-heavy kilns used in concrete production. Each lightweight block, about 5 kilograms, slots into the next using a clever jagged edge, which means no mortar, less labor, and fewer thermal bridges. Reinforcement rods can be added through built-in vertical cores, making them strong enough for load-bearing structures, even in seismic zones. Unlike concrete or brick, Sugarcrete is grown from waste, not mined, giving it a carbon footprint up to 20 times lower. It looks more like compressed earth than concrete, but that's the idea: organic, modular, and easy to handle by hand. Plus, the fibrous material naturally insulates, helping stabilize indoor temperatures and reduce energy use. What was once discarded or burned now builds the future. Cobiax SL transforms concrete slabs from the inside out without looking any different on the surface. What seems like a solid floor is actually a high-performance structure with hollow plastic spheres tucked inside. These recycled plastic voids, locked in steel cages and placed between rebar layers, reduce concrete volume by up to 35%, all while maintaining full structural capacity. The benefit? Lighter slabs, longer spans, and thinner decks, without sacrificing strength, safety, or code compliance. With less dead load, you get smaller foundations, leaner columns, and more open interiors for creative architectural layouts. Cobiax SL meets Eurocode standards for seismic response, fire resistance, and vibration, and it installs like a conventional slab, no new tools or techniques needed. Available in multiple sizes for slabs from 20 to 50 centimeters thick, it brings hidden sustainability to everyday construction. It's smart, efficient design, just beneath your feet. Smart Slab transforms the way we think about concrete ceilings by blending advanced structure with digital precision. Instead of relying on traditional flat slabs, it uses a sculpted ribbed form that reduces material while enhancing performance. The flowing curves and detailed recesses underneath are shaped using 3D printed sand molds, achieving levels of accuracy that standard methods can't match. For the straighter rib sections, laser-cut plywood forms are used. Construction begins with a sprayed layer of fiber-reinforced concrete to create the thin shell, followed by a pour of conventional concrete to form the ribs above. Once the prefabricated parts arrive on site, they're post-tensioned into place, forming a seamless slab that also serves as the finished ceiling. Built-in voids and channels are carefully integrated into the formwork, allowing lighting, wiring, and other services to run through the structure without needing extra space. Harmon curtain walls are what give modern glass towers their sharp, seamless look from the sidewalk to the skyline. These walls aren't structural, they hang from the building's frame like an outer shell. Harmon engineers unitized systems, large, pre-assembled panels that arrive on site ready to install. Each includes aluminum framing, glass, seals, and thermal brakes. Panels are lifted into place floor by floor, locking into position with precision. These systems are designed to handle wind pressure, thermal shifts, and building movement, while still looking flush and flawless. Panels can span multiple stories, with internal drainage, vapor barriers, and expansion joints built in. Even when towers sway inches in the wind, Harmon's curtain walls flex without breaking seals or cracking glass. Since everything is built in a controlled factory setting, field labor is reduced and quality control improves. EMMEDUE Panels proudly display their unique structure instead of hiding it. At first glance, they look like a simple sandwich of foam, wire mesh, and concrete, but this combination offers much more. These panels deliver strength, insulation, and fast installation all in one. Manufactured in the factory, the core is made of expanded polystyrene, usually 60 to 100 millimeters thick, with welded steel mesh on both sides connected by diagonal trusses spaced every few inches. Once on site, the panels are assembled into walls, floors, or roofs and then sprayed with 2 layers of concrete. This process allows the concrete to bond tightly to the mesh, which is securely connected to the foam, creating a rigid, lightweight structural element. Before spraying, the system performs like solid concrete. After curing, the walls meet seismic and hurricane resistance standards in many regions. TBM machines don't roar, they hum with focused precision. These engineering marvels aren't about raw power, but about carving paths beneath mountains and cities, 1 meter at a time. Whether tunneling under rivers, through solid rock, or beneath bustling urban streets, TBMs create routes where traditional digging can't reach. At the front, a giant rotating cutter head slices through soil and stone. Behind, a complex system removes debris and installs precast concrete segments, forming the tunnel lining continuously. Sizes range from just over a meter wide to massive diameters of up to 17 meters, large enough for highways or metro lines. Some TBMs tip the scales at over 4,000 tons and stretch more than 300 feet long. Using GPS, lasers, and sensors, they navigate precisely, curving under rivers and around foundations with millimeter accuracy. Mechanical concrete doesn't just patch potholes, it reimagines the very foundation beneath your wheels. Instead of traditional aggregates or compacted soils for road bases, it cleverly reuses old tires, specifically the sidewalls of steel-belted radial tires. These are transformed into confinement cylinders that securely hold crushed stone like never before. Here's the process. The tire tread is stripped away, leaving a durable circular ring of reinforced rubber. These open rings are lined up and packed with gravel or crushed stone, creating a confined core that resists shifting, spreading, and settling. It's a straightforward, scalable solution that needs no special materials or heavy equipment for installation. What sets it apart is the unique way confinement works. When vehicles drive over regular unbound stone, the load spreads out, causing the stone to push outward or settle over time. Basetrac, a geogrid reinforcement system designed to stabilize weak subgrades before building roads, foundations, or embankments. Unlike traditional base layers, it doesn't pave but acts like a skeleton beneath the soil, spreading loads and reducing rutting. Made from high-strength polyester yarns or fiberglass coated for UV and chemical resistance, Basetrac offers tensile strength with an open grid structure that allows gravel or crushed stone to lock into place. This mechanical interlock creates a reinforced composite layer, preventing shifting and deformation. Installation is quick. Simply unroll Basetrac over the prepared ground, add aggregate, compact, and continue building with no curing needed. It often cuts fill layer thickness by up to 50%, extending pavement life under highways, railways, and runways, especially in soft soils. Its simplicity means no special equipment is required, making a lasting difference in stability and maintenance costs. ThermaBead doesn't come in rolls or sheets. It's a flowing cavity wall insulation system that uses tiny expanded polystyrene beads injected through small holes to fill every nook and cranny. These beads create a continuous, high-performance thermal barrier that's quick and clean to install. Once inside, the beads stay firmly in place, locked by a special bonding agent that prevents settling over time. About the size of a grain of rice and lightweight, the round beads are pumped into the cavity under controlled pressure, navigating around wiring and fixtures to reach spots that traditional boards or bats can't. The adhesive sprayed with the beads forms a stable matrix, maintaining its shape without sagging or shifting, even years later. ThermaBead systems can typically achieve U values as low as 0.27 W/m2K, depending on wall type and depth, delivering a significant thermal upgrade, especially for older or uninsulated cavity walls. Origami Structures transform flat, rigid materials into strong, foldable forms inspired by the ancient paper folding art. These designs use precise geometry to turn thin sheets of aluminum, polymers, or composites into stiff, load-bearing structures. Each fold adds strength, allowing materials to act like beams or trusses when expanded. Folding motions vary, from fan-like openings to accordion-style pop-ups, enabling compact transport and rapid deployment without cranes or heavy foundations. Ideal for emergency shelters, mobile offices, or pavilions, these systems offer portability and speed. With advanced materials and locking mechanisms, they can be semi-permanent or modular, adapting as needed. Some incorporate solar panels, insulation, or acoustic layers within folds. Digital modeling ensures every crease accounts for material thickness and connection points, delivering smooth folding and robust structural performance. BLANKE PERMATOP wall, where innovative design meets efficient heating, right on the wall. This radiant system transforms vertical surfaces into sleek, silent heat sources, eliminating the need for radiators or underfloor tubing. At its core are modular EPS, expanded polystyrene, panels with preformed grooves for flexible PEX pipes that circulate warm water just beneath the wall finish. Once plastered or coated, the system is completely invisible, just clean, even heat. Operating at low temperatures, 30 and 40 degrees C, it's ideal for use with sustainable energy sources like heat pumps and solar systems. Unlike forced air or traditional systems, it offers dust-free comfort and fast response times thanks to the shallow pipe depth. System 3E. Think of building like stacking toy blocks, fast, clean, and mortar-free. This system uses large, lightweight ceramic blocks made with expanded perlite. Engineered with tight tolerances, they lock together precisely, no glue, no cement. These blocks do more than hold structure, they insulate, breathe, and streamline the build. Naturally vapor permeable, they regulate moisture and prevent buildup inside walls. Their smooth finish means no plaster needed, just paint or coat directly. The magic? Dry stacking. No curing delays, no mixing, almost zero waste. Crews can raise home shells in mere days. Less dust, less noise, fewer tools. They're frost-proof, fire-resistant, and stable through temperature swings. Whether it's a scorching summer or freezing winter, they won't warp or crack. Because it's modular, repairs and changes are simple later on. System 3E isn't just fast, it's future-ready construction.